Okay, I hope I'm audible to all the students who are attending this lecture. We start with a new topic in class 12th mathematics. This is called vector algebra. Okay, it's a completely new topic in class 12th mathematics. Okay, so basically the applications of vectors is something which students do in physics. However, we will be looking at this particular concept from mathematical point of view as well. Okay, so first of all we should know what is a vector. So let's write the definition of a vector. Okay, a quantity that has magnitude, quantity that has magnitude as well as direction, quantity which has magnitude as well as direction is called a vector. Okay, now you must have studied this in physics as well. Basically, any quantity which only has magnitude is called a scalar. Okay, so you can write a note: a quantity that only has magnitude, a quantity that only has magnitude is called a scalar. So students should be able to understand the key difference between a vector and a scalar. When we talk about a scalar quantity, it only has magnitude. We don't talk about direction. However, if we have a quantity which has a given magnitude as well as a given direction, that particular quantity is called a vector. Now, how we denote a vector? So let's understand this. So our next heading now is notation of a vector. Notation of a vector. So let us see how we draw a vector. So I am taking 2 points on the screen. This is point A, this is point B. Okay. And if I join these points using a line segment, I get the vector AB. Okay. Now you can see as we are moving from point A to point B, there is a magnitude attached to it. There is also a direction. Now, which direction is this? You can see from point A, it is northeast. When we are moving from point A to point B, it is the northeast direction. Okay, so we can clearly see in the above diagram, we can see that the directed line segment, the directed line segment AB, okay, we write it like this. We write a vector like this, okay, or I can also write it as A with an arrow upstairs. Okay, A with the arrow on the top. So the directed line segment is AB or vector A. Okay, so this is called the vector. The directed line segment AB is called the vector, which has both magnitude as well as direction. Okay, so let's further write a note. The point A from where the vector AB, the point A from where the vector AB starts is called the initial point, is called the initial point and the point B, and the point B where the vector ends, point B where the vector ends is called the terminal point. Okay, point B where the vector ends is called the terminal point. Okay, then we can further write the distance between the initial and the terminal point, the difference between the initial point and the terminal point is called the magnitude of the vector. It is called the magnitude of the vector. Okay, it's also called the length of the vector. Okay, so I can write in brackets also called the length of the vector. So I hope that students have understood about the initial point, the terminal point, and the magnitude. The point from where the vector starts is called the initial point. Clearly, you can see the line segment AB is starting from point A. It is a directed line segment because you can see it is going in the northeast direction. Okay, the point where the vector is ending, that is called the terminal point. Clearly in the picture you can see that B is the terminal point, the vector is ending at that point. Okay, and you can clearly see that how do we denote a vector? AB with a line on the top, okay, or small a with an arrow on the top. Why do we draw an arrow? Because it is showing that it has magnitude as well as direction attached to it. Okay, now all of us know that the distance cannot be negative, so the length, since the length cannot be negative, the magnitude of a vector will always be positive. It will always be greater than 0. Okay, so let's write a note on this. Let us write a note. Since the length is never negative, since the length is never negative, our magnitude of a vector will be greater than 0. Guys, this is how we denote the magnitude. Okay, so this is how we denote the magnitude. So whenever we find the magnitude, it can never be negative. The length always has to be positive. Okay, so now let's talk about position vectors. So within vectors, let us look at position vectors. So we will be considering the 3D space now. Students can recall in class 11th mathematics, you had done the lectures on 3D geometry, where we had the 3-dimension space. Okay, so now let us visualize a vector in a 3D space. So consider a point capital P in the space having the coordinates x comma y comma z. You can think of a particle which is floating in the 3D space, and that particle has coordinates x comma y comma z. Okay, these are the coordinates with respect to the origin. So these are the coordinates with respect to the origin. All of us know in 3D space the coordinates of the origin are 0 comma 0 comma 0. Okay, now we are going to discuss about the vector OP. Okay, the origin is denoted by capital O. You can see on the screen I am darkening capital O. This means the origin with coordinates 0, 0, 0. So I can say then the vector OP having O and P as its initial and terminal points respectively, having O and P as its initial and terminal points respectively, is called the position vector of P. It is called the position vector of the point P with respect to the point O, or with respect to the origin. O denotes the origin here. Okay, so we can visualize it. So you can see I am drawing a diagram on the screen which helps you to visualize the 3D space. So guys, you can see there are three axes. You can see that in the 3D space, there are three axes: the x-axis, the y-axis, and the z-axis. Now, close your eyes and imagine that in the 3D space, there is a particle floating. Think about a particle lying in the 3D space. Let us call this as P of x, y, z. This is my origin. The coordinates of the origin are 0, 0, 0. Now see, I am drawing a vector. Or I can draw the vector in red so that it's easy for you to distinguish. So you can see that I am drawing a vector OP. Suppose we call this as vector R. So you can see in the 3D space, we have drawn a vector. Again, it is a directed line segment. It has a magnitude as well as direction. O is the initial point. O is the initial point of this vector. P is the terminal point of this vector. P is the terminal point of this vector. And what is the magnitude? Now guys, if I find the magnitude of this vector, how will I find the magnitude? So magnitude of the vector OP, magnitude of the vector OP is, I can write it like this: OP, magnitude of the vector OP is, now guys, we can apply the distance formula. All students recall from class 11th mathematics, recall distance between 2 points x1 comma y1 comma z1 and x2 comma y2 comma z2 is given by, all of you can recall the distance formula: x2 minus x1 square plus y2 minus y1 square plus z2 minus z1 square. This is the distance formula which you can recall from class 11th mathematics when you had done introduction to 3D geometry. Now guys, distance between x comma y comma z and 0 comma 0 comma 0 will be x minus 0 square plus y minus 0 square. Okay, x minus 0 square plus y minus 0 square plus z minus 0 square. So guys, my vector will be square root of x square plus y square plus z square. This will be the magnitude of the vector OP. And what we have applied is the distance formula between 2 points in the 3D space, which we had learned in class 11th mathematics. Okay, so now Having visualized the vector in the 3D space, now let's go deeper and talk about the direction cosines. So that's our next heading, direction cosines. Okay, so again guys, to visualize this, let's first look at the diagram which I am drawing. It will help you to visualize it. So again, you can look at the 3D space which we are drawing. Look at the 3D space which we are drawing. Okay, x-axis, y-axis, and the z-axis. Now guys, again consider a point P in the space which corresponds to the coordinates x, y, and z, and this is my origin which corresponds to 0, 0, 0. Now you can see that I am drawing a vector R. If I join OP, okay, then this is my vector R. Okay, and suppose this vector is making the angle alpha, beta, and gamma with all the axes respectively. So what is the angle made by this vector with the x-axis? So you can see in red, this is the angle made with the x-axis. Let me call it alpha. This is the angle made with the y-axis. Let me call it beta. And this is the angle in brown color made with the z-axis, which we can call as gamma. So alpha, beta, and gamma are the angles made by the vector. So we can write this. So consider the position vector. Consider the position vector OP, which we denote by R with an arrow, of the point P, which corresponds to the coordinates x, y, z. Okay, so consider this. The angles alpha, beta, gamma made by the vector R with the positive direction directions of the x, y, and the z axis respectively. Okay, are called its direction angles. So guys, what are direction angles? The angle made by the vector R with the x-axis, y-axis, and the z-axis are called the direction angles. So I can say alpha, beta, and gamma are called the direction angles. Alpha, beta, and gamma are called the direction angles, which are made by the vector R with the x, y, and the z-axis. Now let's continue further with the explanation. I'm doing it on the right of the screen. You can see. Okay. The cosine of these angles, that is cos alpha, cos beta, and cos gamma, are called the direction cosines. These are called the direction cosines of the vector R. These are called the direction cosines of the vector R and are denoted by L, M and N respectively. So guys, alpha, beta and gamma are called the direction angles. If I take the cosine of these angles, so cos alpha, cos beta and cos gamma are called the direction cosines of the vector R. So I can say guys, my L is nothing but cos alpha, my M is nothing but cos beta and my N is nothing but cos gamma. Together these are called the direction cosines. Alpha, beta and gamma are called the direction angles. Alpha, beta and gamma are called the direction angles. L, M and N are called the direction cosines. Okay, so I hope that students have understood the concept of direction angles and direction cosines. Okay. Now guys, if I take some points A, B and C, so you can see I'm taking some points. Let this be a point on the x-axis, let B be the point on the y-axis and let C be the point on the z-axis. Okay, so you can look at if I join points A and P. So guys, now I am erasing some stuff. You know this is the origin. You know alpha, beta and gamma now. Okay, so what I am doing now, I am joining points A and P. You can see, let me join points A and P. So I have joined points A and P. I have joined points B and P. And I am also joining points P with C. So basically the point P, I have joined with all the points on the, I have joined with point A on the x-axis, point B on the y-axis and point C on the z-axis. And guys, if you again try to figure it out, you will see that these are all right angles. This is also 90 degrees. This is also 90 degrees. This is also 90 degrees. If you just see it, try to visualize it. This is also 90 degrees. Okay. So look at what I am trying to write now. So I am erasing this part. All of us know alpha, beta and gamma are direction angles. Cos alpha, cos beta, cos gamma, which we call as L, M and N are the direction cosines. Now let's further move forward. What we have done is we have joined points P with points A, B and C. You can see that in the above diagram, triangle OAP is right angle triangle. You can see triangle OAP. Now again guys, close your eyes and try to visualize it. When you visualize it, you will see that OAP is actually a right angled triangle. Okay, just try to tilt it up. You will see it is forming a right angle triangle at point A. Okay, so triangle OAP is a right angle triangle. And what is cos alpha? What is cos of alpha? All of us know cos theta is nothing but base upon hypotenuse. So if you look at OAP, cos alpha is nothing but the base. Now what is the base? The base is, so guys, this distance is x. Okay, this distance is y, and this particular distance, this whole distance is nothing but z. So if you look at cos alpha is what? It is the base, which is x, upon the hypotenuse, What is the hypotenuse? The hypotenuse is nothing but r. So it is the base upon the hypotenuse. Remember, hypotenuse is the side opposite the right angle. So side opposite this right angle is nothing but OP, which is nothing but R. Similarly, I can say, triangle OBP is right angle triangle. So guys, what will cos beta be? Now focus on OBP. OBP. Okay. So again, it's the base. The base is nothing but OB. OB is nothing but Y. So guys, 1 minute. Let me correct the mistake. This is Y. This distance is Y. So base is Y upon the hypotenuse is again R. Okay. And similarly, triangle OCP is also a right angle triangle. So what will cause gamma be? So look at OCP. Look at OCP. Cos gamma will again be the base. Now what is the base? Base is nothing but Z. Again guys, this is Z. Let me correct it. This is Z. Base is Z upon hypotenuse is R. So now it's absolutely correct. All of us know that cos theta is base upon hypotenuse. Now from the origin, if you look at triangle OAP, cos alpha is nothing but the base upon hypotenuse. Triangle OBP, cos beta is the base upon hypotenuse. Triangle OCP, cos gamma is the base upon the hypotenuse. So guys, this implies my x is equal to r times cos alpha. But what is cos alpha? Cos alpha is equal to L. So RL, I can say x is equal to RL. This implies my y is equal to r times cos beta. But guys, what is cos beta? M. So Rm. This implies my z is equal to r times cos gamma. But what is cos gamma? N. So my coordinates of point P are RL, Rm, Rn. These are called the direction ratios of the vector R. So I can write on the top of the screen, you can see RL, Rm, Rn, okay, are called the direction ratios, of the vector R. Okay, and we denote them by A, P, and C respectively. Okay, and are denoted by A, B, and C respectively. So guys, what we have learned is alpha, beta, gamma are called the direction angles. Cos alpha, cos beta, and cos gamma are called the direction cosines. RL, Rm, and Rn are called the direction ratios, where L is cos alpha, M is cos beta, and N is cos gamma. You can see that the direction ratio is proportional to direction cosine because it's R times L. L itself is cos gamma. R times M. M itself is cos beta. R times N. N itself is cos gamma. So the direction ratios of the vector are proportional to the direction cosines. And the direction ratios are denoted by A, B, and C respectively. So A is equal to RL, B is equal to Rm, and C is equal to Rm. And then all students can write a note, and this is where we stop. L square plus m square plus n square is always equal to 1, but a square plus b square plus c square is not equal to 1 in general. All students can write this as a note. L square plus m square plus n square will be equal to 1 always, where L, M, and N are the direction cosines. But a square plus b square plus c square will not be equal to 1 in general, where a, b, and c are the direction ratios. So I can say the sum of the squares of the direction cosines is equal to 1, but the sum of the squares of the direction ratios may not be equal to 1 in general. Okay, so guys, this is where I stop in this lecture. What we have primarily covered in this lecture is the concept of vector, position vector, how we denote it in the 3D space, the concept of direction angles, direction cosines, and direction ratios. In the next lecture, I will be talking about the various type of vectors we have. So this is where I stop. I hope all students have enjoyed this lecture. Any doubt, you can unmute your mic and ask, or call up or mail me your doubts at divineschoolofeconomics@gmail.com. So this is where I